In this video, we will be learning about complex numbers and how to do geometry with complex numbers. To do that, we will be using a problem from ISI Entrance 2012. This is objective problem number 13. Here is the statement of the problem. We have a fixed real number which is given as a. It's also given that a is greater than -1. Now we want to find out the locus of z, all complex numbers z, such that a given condition is satisfied. And what is the condition? The condition is absolute value of z minus ia is equals to imaginary part of z plus 1. We want to find out all such complex numbers z. When I say locus, you can think of it like this, that find the set of all complex numbers z which satisfies this condition. Now if you plot those complex numbers in the Argand plane, then what is the picture that you will get of that collection of complex numbers? What is the picture that you will get of the collection of all such complex numbers z such that this particular condition is satisfied? Now there are two ways of doing this problem. One is the brute force method, and the second one is the conceptual method. I like the conceptual method more because it actually teaches us a lot about geometry and complex numbers. But first, let's look at the brute force method. This is the method you will probably be using if you first see the problem. So if I take this equation, z minus ia, absolute value of that, equals to imaginary part of z plus 1. Now suppose z is equals to x plus iy. This is a general form of any complex number. Then you can replace this value of z here, or the expression for z here. So x plus iy minus ia is equal to, imaginary part of z is simply y plus 1. So what do you get? Well, you get absolute value of x plus I times y minus a is equals to y plus 1. Now, absolute value of z, what is the meaning of that? Well, if z is a complex number, x plus iy, then the absolute value of z is the distance of it from the origin, which is basically square root of x square plus y square. So we can find out the absolute value of this particular complex number inside the parentheses, and that is square root of x square plus y minus a whole square. This is equals to y plus 1. Now you can simply square both sides. You could square both sides to get x square plus y square minus 2ya plus a square equals to, that's squaring the right side, you get y square plus 2y plus 1. The y square and y square cancels, and you get x square equals to 2ya plus 2y plus 1 minus a square. So this particular equation is of course an equation of a parabola. If you know the general form of the equation of a parabola, you will immediately recognize this. Then x square, you can also write it as x square equals to y times 2a plus 2 plus 1 minus a square. So general form of a parabola. So the answer to the question is, the picture is that of a parabola. Now you have to be careful to understand it from the conceptual part as well. Because certainly this is a brute force method, it will work and it will give you the final expression, but the conceptual method is so much better. You will see it in a moment. Let's go to a new page and let's work with the conceptual method. So what is the expression? Z minus IA equals to imaginary part of Z plus 1, right? So let's draw a picture so that we understand what's going on. This is the x-axis, this is the y-axis, this is the origin, and this is the point -1. So I will just draw dots here. So this is the line y equals -1. Remember, the problem says that the value of a is greater than -1. The value of a is greater than -1. So we will be using that. So let's mark this line. Now we have IA. IA is a point on the y-axis. Any point on the y-axis is I times something, right? This is maybe 2i, this is 3i, this is 1i, this is maybe 0.5i. So every point on the y-axis is I times some real number. So we have a point IA which is above this dotted line, because the value of a is greater than -1, so it's above this dotted line. So let's mark it here. Let's call this the point P, which is equals to IA. Now we want all such complex numbers. We want all such complex numbers Z whose distance from P is equal to the distance from the y equals to -1 line. The distance from P is equals to the y equals to -1 line. Why? Because this is this little part above the y-axis. This is the imaginary part of Z. That's y. And +1 tells you the distance from the x-axis to y equals to -1 line. So this is 1. So this entire distance is y plus 1. So we have a very beautiful explanation now that we have a complex number Z whose distance from P is equal to the distance from this particular line. The distance from P is equal to the distance from this particular line. So what is the locus of all such points whose distance from a fixed point is equal to the distance from a line? You know, if you have studied coordinate geometry, then that is precisely the locus definition of a parabola. So even without any calculation, just by looking at this expression, you can actually tell that the locus of Z is a parabola. In fact, it's a parabola opening upward. And of course, it's clear from the brute force method as well. Always think about complex numbers problems in these geometric terms. It will tell you a lot more about the story behind the equation. Keep on doing great mathematics. I will see you in the next one.